Hello. Today we have a practical lesson on work and energy. And let's start solving the following question. A body has a velocity of 3.5 meters per second and kinetic energy of 14 joules at the initial moment of time. At a time instant of 5 seconds, the body has a velocity of 4.7 tenths of a meter per second. Questions. What is the mass of the body? What is the kinetic energy at time 0.5 seconds? What is the work at time 0 to 5 seconds? What was the force acting on the body during this time interval? So we have some questions, and let's start by writing down what we have in mind. We know that the initial velocity of this body is 3.5 tenths of a meter per second. We also know that the kinetic energy of the body at the same moment in time is 14 joules. We also know that at a moment in time, 5 seconds, the body has a finite velocity. For this case, the motion is 4.7 tenths of a meter per second. So now the questions. We need to determine the mass of the body. We need to determine the kinetic energy. We also need to determine the work. And we also need to determine the force that acted on this body. The four quantities we're going to determine. Let's start in order. Let's see if we can determine the mass of a given body, in this case if we have a set of such data available. To begin with, we can look at the fact that we know the kinetic energy at the initial moment of time. Let's start there. Let's spell out the value of this energy. Recall the formula that it is 1 second times the mass of the body and times the velocity. In this case, again, initial velocity squared. Given that everything is known, we can find the mass of this body from here. So, it would be 2 times the kinetic energy and divided by the square of the velocity for a given moment in time. Let's substitute a value. So 2 times 14 and divided by 3.5 tenths squared. Given that we take all the data in the SI system, so the unit of mass in this case will be the kilogram, and we get the value of 2.3 tenths, the approximate value of a kilogram. The answer is for mass. The next question. This is the calculation of the kinetic energy already at the final moment in time after 5 seconds, when the velocity has reached 4.7 tenths of a meter per second. Given that you and I have already determined the mass, we can calculate this energy quite easily. 2 times the known mass and the final velocity squared. Let's do the math. So mass is 2.3 tenths and velocity is 4.7 tenths squared. In this case, the dimension is joule, because we've substituted all the data in the SI system, and we get an approximate answer, 25.4 tenths of a joule. That would be the value of the final kinetic energy. So, next question. This is work. What is equal to the work done by some particular force in accelerating a given body? You can solve it in different ways here, depending on which way is immediately obvious or more convenient for you, or in what order you begin to solve this problem. Also, the choice of formula depends on that. But given that you and I know the final energy and the initial energy kinetically, you and I can recall that work is a measure of the change in energy of a body. So in the form of a formula, we'll write it down as follows. And having the value of both of these energies, we can give you the answer to work right away. So we've got 25.5, 4 tenths of a joule minus 14 joules. And we get the expression 11.4 tenths of a joule. That's the work done by some force. Well, we can also calculate the force itself in terms of what we have available to us in terms of the mass of the body. We know how the velocity of this body changed, over what time it changed. So here we can plug in, for example, Newton's second law, which will allow us to calculate this force, mass times acceleration. And here we will write the acceleration as the rate of change of velocity, that is, by how much the velocity of this body has changed over a specified period of time. And let's do the calculation. So 2.3 times the difference between the two velocities, and divide by the time of the motion. So, well, roughly the answer is 0.6 tenths. 6 tenths of a Newton is the magnitude of this force. So here we have applied for calculation of this problem the basic formulas concerning calculation of kinetic energy, connection with work, and remembered plus Newton's second law. I remind you that we could also determine the force through work, because there is, not forgetting the formula that work is the product of force by displacement, and of course it can also be introduced and used here. So it all depends on how you look at this problem and what method of solution you see. Well, of course, we'll familiarize ourselves with other methods in the next lessons. Goodbye, everyone.